The universe is under no obligation to make sense to you. It simply is. We look up at the night sky, a vast and silent ocean of stars, and we feel a sense of wonder. We are a part of this cosmic drama, a brief flicker of consciousness on a small, wet rock orbiting an unremarkable star. We have stories about how we got here. Science gives us one, religion gives us others. But what if there is another story? What if the truth is stranger than we have ever dared to imagine? What if our very existence is not a product of this world alone? What if we are the result of an experiment, a project, a creation? This is a powerful question. It challenges our most fundamental assumptions about who we are and where we come from. It forces us to confront the vastness of time and the sheer improbability of our own intelligent awareness. To consider it is not to abandon science, but to embrace the very spirit of scientific inquiry, to question everything, especially what we believe we already know. We must be willing to follow the evidence wherever it may lead, even if it leads us to conclusions that reshape our understanding of humanity's place in the cosmos. It's a journey that begins not with answers, but with a profound and humbling sense of curiosity, a desire to pull back the curtain on the greatest mystery of all. The idea feels like science fiction, and for a long time, that is all it was. The stuff of pulp magazines and late-night movies. Before we can explore the extraordinary, we must first understand the ordinary. The prevailing scientific explanation for human origins is the theory of evolution by natural selection. Charles Darwin famously articulated this idea. It is one of the most well-supported theories in science. It is elegant and powerful, explaining the vast diversity of life on Earth. It does not require any outside help. It doesn't need a cosmic creator. It doesn't need an alien geneticist. All it needs is a few simple ingredients. Variation inheritance, a struggle for survival. It's written not in the stars, but in the rock's fossil's genetic code of our planet. The process is straightforward, yet its results are astonishingly complex. Within any population, there are small, random variations. Like a family of siblings, none are perfect copies. Some variations give a slight edge. A slightly longer beak to reach more food, slightly better camouflage to avoid a predator, a slightly stronger immune system. Those heritable traits make individuals more likely to survive and reproduce. Over many generations, small advantages accumulate, and the population changes. It's slow, patient, and unguided. Fossil evidence testifies to this long journey. Paleontologists have unearthed a series of hominid fossils documenting our lineage. We can see gradual changes over millions of years. Australopithecus, bipedalism. Homo habilis, increasing brain size. Homo erectus, increasing brain size. Homo sapiens, emergence. Each fossil is a snapshot in time, a piece of the puzzle. No sudden jumps, just step-by-step progression from primate ancestors to modern humans. Genetics adds an even more compelling layer. Our DNA is a living historical document. Comparing genomes shows what evolution predicts. Our closest living relatives, chimpanzees bonobos, our DNA is about 98.8% identical to theirs. This genetic similarity is a molecular family resemblance, pointing to a recent common ancestor. We can even find fossil genes, vestiges of ancient DNA still in our code. This mountain of evidence from independent fields makes natural evolution the bedrock of modern biology. Now, let us turn our gaze to a different possibility. Let us, for the sake of argument, entertain a radical alternative. The ancient astronaut hypothesis, or the alien creation theory, starts from a place of skepticism about the standard model. It looks at the same evidence, the fossil record, our DNA, our history, and asks, is that all there is? This theory proposes that natural evolution alone is not sufficient to explain the sudden and dramatic emergence of Homo sapiens. It suggests that at some point in our distant past, an intelligent extraterrestrial civilization visited Earth and intervened directly in our development. This intervention could have taken many forms. Perhaps these cosmic visitors found a promising primate species, an early hominid, and decided to accelerate its evolution. They could have used advanced genetic engineering, artist rendering, a humanoid alien manipulating a glowing strand of DNA with an early hominid in the background. A technology we are only just beginning to explore ourselves to modify that creature's DNA. This uplifting process might have been responsible for the rapid increase in our brain size, our capacity for complex language, and our self-awareness. In this scenario, we are not just the product of blind natural processes. We are, in a very real sense, a genetically modified organism. We are the result of a deliberate act of creation, not by a deity in the clouds, but by a biologist from another star system. Why would they do it? The motives of such beings are, of course, impossible to know for sure. Perhaps it was a scientific experiment. They might have seen Earth as a vast planetary laboratory, a place to seed and observe the development of intelligent life. Or maybe their motives were more altruistic. They could have been cosmic gardeners, spreading the seeds of consciousness throughout the galaxy, seeing it as their duty to foster intelligence wherever they found the potential for it. A less comforting thought is that they might have created us for a purpose, as a workforce, as soldiers, or even as a resource to be harvested later. This hypothesis is compelling because it offers potential answers to some of our species' most puzzling questions. It could explain the missing link that some people feel exists in the fossil record, the perceived gap between earlier hominids and modern humans. It could account for the sudden explosion of art, culture, and technology that appeared relatively recently in our history, known as the Great Leap Forward. While science has plausible explanations for these phenomena based on natural processes, the alien intervention theory provides a single, dramatic cause. It reframes our entire history as a story not of accidental evolution, but of purposeful design. If aliens did tamper with our genetic makeup, the most direct evidence would be hidden within our own DNA. Our genome is a 3 billion letter-long code that carries the instructions for building and operating a human being. Proponents of the alien hypothesis suggest we should be able to find anomalies in this code sequences that do not appear to have an evolutionary origin. They argue we might find a section of our DNA so complex, so out of place it looks less like a product of random mutation and natural selection, and more like a snippet of manufactured, intelligently designed code. It would be the ultimate biological signature. One area of interest is what has often been called junk DNA. This refers to the vast portions of our genome that do not code for proteins. For a long time, scientists thought these sections were evolutionary leftovers with no function. However, we are now discovering much of this junk plays a crucial role in regulating gene activity. The alien hypothesis asks if there could be something more hidden in these non-coding regions. Could there be a compressed message, a mathematical constant, a galactic map tucked away in our cells, waiting for a species advanced enough to read its own source code? It's a tantalizing idea. A message in a bottle on a cosmic scale. Another potential clue could be the apparent speed and timing of our cognitive evolution. The human brain is an incredibly complex and energy-intensive organ. The leap in cognitive ability from Homo erectus to Homo sapiens was profound and, in geological terms, quite rapid. While evolutionary biologists have proposed various environmental and social pressures that could have driven this growth, some find the pace of this change suspicious. Could a targeted genetic upgrade from an outside intelligence explain this sudden explosion in brainpower and creativity? They might have inserted or activated specific genes, like the FOXP2 gene associated with language, to jumpstart our journey toward civilization. However, we must be cautious. The claim that a piece of DNA is unnatural is an extraordinary one. The vast majority of geneticists would argue our entire genome can be explained through known evolutionary mechanisms like gene duplication, viral insertions, random mutations. What might look like a designer's signature to an untrained eye could, to a geneticist, be a clear footprint of a well-understood natural process. To prove an alien origin for a piece of our DNA, we would need to exhaustively rule out every possible natural explanation. Section 5. Clue number 2. Fingerprints on stone and metal. Beyond our biology, could evidence of alien intervention be found in the things our ancestors built? This is the realm of paleoarchaeology and the search for out-of-place artifacts, or UPART, objects found in the archaeological record that seem too technologically advanced for the culture that supposedly created them. Proponents point to the Antikythera mechanism, an ancient Greek astronomical calculator of staggering complexity. Pumapunku, precision-cut stones that fit so tightly no knife will fit. The question is, how did ancient people, with supposedly primitive tools, achieve such feats? The argument is that they didn't, at least not alone. The hypothesis suggests that our ancestors were given a technological boost. Perhaps the visitors taught advanced construction techniques, metallurgy, or astronomy. Sighted monuments, Great Pyramids of Giza, the massive stone heads of Easter Island, the intricate lines in the Nazca Desert. These have been cited as potential evidence of ancient knowledge transfer. The builders of these monuments, the theory goes, were not just clever humans. They were students of extraterrestrial teachers. These megalithic structures are not just tombs and temples. They are monuments to a forgotten chapter of cosmic contact, a legacy left in stone. We must, however, apply a healthy dose of scientific skepticism. Archaeologists and historians have spent careers studying these ancient cultures, and they have proposed very plausible, human-centered explanations for many of these mysteries. They show how massive stones could be moved with simple machines, clever engineering, and a large, well-organized labor force. They demonstrate that ancient peoples had a sophisticated understanding of astronomy, mathematics, and architecture, developed over centuries of observation and practice. To suggest they needed alien help can be seen as underestimating the ingenuity and capability of our own ancestors. It's a classic case of what we call an argument from ignorance. Just because we don't immediately know how they did something, it doesn't mean aliens did it. Furthermore, the evidence for these advanced technologies is often ambiguous. The precision cuts at Pumapunku could have been achieved with simple stone and bronze tools, patience, and immense skill. The Antikythera mechanism, while brilliant, is still made of materials and based on astronomical knowledge consistent with ancient Greece. If an advanced alien race had truly intervened, we might expect to find something far more definitive. An alloy that couldn't be made on Earth, a tool with microscopic machining, or a power source that defies our understanding of physics. The absence of such a smoking gun is a significant problem for this line of reasoning. Section 6. Clue number 3. Whispers from the ancient world. The third category of evidence is perhaps the most captivating and the least scientific. It is found in the myths, legends, and religious texts of ancient cultures all around the world. Proponents of the alien hypothesis pore over these old stories and see not just mythology, but misinterpreted history. They suggest that when our ancestors wrote about gods descending from the heavens in fiery chariots, they weren't describing supernatural beings. Instead, they were doing their best to describe what they saw: advanced spacecraft and their occupants. The magic of the gods was simply technology that they could not comprehend. Look at the stories with this lens and they begin to change. The Vimanas of ancient Indian texts, described as flying palaces, could be reinterpreted as detailed descriptions of aircraft. The biblical story of Ezekiel's wheel, with its complex, interlocking rings and flashes of light, sounds to some like an encounter with a complex piece of machinery. The sky gods of the Maya, the sky gods of the Egyptians, the sky gods of the Sumerians, agriculture, law, astronomy. The flood myths common to many cultures could be a garbled memory of a planetary scale event orchestrated or observed by these visitors. This reinterpretation of myth is a powerful storytelling tool. It connects our modern, technological world with the deep spiritual past of our ancestors. It suggests a shared experience of contact that was encoded into the foundational stories of nearly every civilization on Earth. It implies that humanity has never truly been alone, and that the memory of our creators has been with us all along, hiding in plain sight within our most sacred tales. The gods were not gods, they were astronauts, and their miracles were not magic, they were engineering. It is a narrative that attempts to unify the myths of humanity into a single, cohesive story of extraterrestrial contact. But here, we are on the very shakiest of ground. This is not science. This is literary interpretation. There is no way to test it. Myths are, by their nature, flexible and symbolic. Convey cultural values, explain natural phenomena, explore the human condition. Attributing these stories to aliens requires us to ignore the rich cultural, psychological, and social contexts in which they were created. While the parallels are intriguing, it is far more likely that different cultures independently developed similar archetypes. Sky gods, flying vehicles, catastrophic floods, because they were all human beings grappling with the same fundamental questions and observing the same natural world. Section 7. How we could actually know. The scientific method. So, we have a fascinating hypothesis and several categories of ambiguous clues. How do we move from speculation to science? How could we test this idea? The answer lies in the scientific method, formulating testable predictions and searching for evidence to confirm or deny them. The hypothesis, if true, should leave concrete, physical evidence we can analyze, something we can put under a microscope or into a mass spectrometer. The burden of proof is on those proposing the extraordinary. In genetics, the path forward is clear but incredibly difficult. Sequence genomes of thousands of individuals from diverse populations, sequence genomes of our closest primate relatives, all with unprecedented accuracy. Use powerful computers to search for specific, non-random patterns, a signal in our DNA that can't be explained by known evolutionary processes. A complex mathematical sequence. A section of code identical across all humans but absent in other species, a genetic switch of immense complexity. Finding such a signal would be a monumental discovery. In archaeology, look for a definitive out-of-place artifact, not a well-cut stone, something undeniably manufactured by non-human technology. Imagine a small object buried deep in an undisturbed 200,000-year-old stratum. Analysis finds it is pure, single-crystal tungsten, formed into a microscopic gear. That would be evidence. That would be a game-changer. It would require careful, meticulous fieldwork and willingness to investigate anomalies without prejudice or wild leaps. Be open to the possibility, but demand the highest standard of proof. Ultimately, the most profound confirmation could come from space. If we were created or visited, they might still be out there. SETI is part of this search. Listening for radio signals asks, "Is anybody out there?" A received message containing a portion of our own genetic code would be undeniable. Or as exploration grows, we might find evidence in our solar system. An ancient probe on the moon, a forgotten base on Mars, a marker left in the asteroid belt. Section 8. What it would mean for us. Let's imagine for a moment that we found it. We discover the smoking gun, the unambiguous genetic signature, the undeniable alien artifact. The hypothesis is confirmed. We were, in fact, created or modified by an extraterrestrial intelligence. What would happen the next day? The impact on human society would be staggering, touching every aspect of our lives: science, religion, philosophy, politics. It would be a fundamental recalibration of our identity. We would no longer be the improbable children of Earth, but the engineered descendants of a star-faring people. The feeling of cosmic loneliness would be replaced by a whole new set of existential questions. Our religions and belief systems would face an unprecedented challenge. The revelation of a biological, extraterrestrial creator would force a profound reevaluation of these faiths. Some might collapse, unable to reconcile their doctrines with the new reality. Others might adapt, reinterpreting their creator gods as a folk memory of these ancient astronauts. New belief systems would undoubtedly emerge, centered around the worship of our makers or the philosophy they left behind. It would trigger a spiritual crisis and a renaissance simultaneously. Our science would be revolutionized. We would have definitive proof that life exists elsewhere, and that intelligence is not unique to Earth. The biology of our makers would become the most important field of study. Their technology, if we could understand it, could solve our most pressing problems, from disease, aging, energy, climate change. But it would also be a humbling experience. Our own scientific achievements would be contextualized as primitive rediscoveries of knowledge our creators possessed eons ago. We would shift from being the pioneers of intelligence to being the students, a species with a cosmic legacy to live up to. The social and political ramifications would be immense. Would humanity unite in the face of this revelation, finally seeing ourselves as one people with a shared cosmic origin? Or would we fracture? Nations might vie for control over alien artifacts or knowledge. Fear and xenophobia could arise. If our creators made us, could they also unmake us? What was their purpose, and do they intend to return? The discovery would force us to mature as a species, to confront our tribal instincts and decide whether we will face our new reality with unity and wisdom, or with the same fear and division that has defined so much of our history. Section 9. The universe is waiting for our questions. The universe is waiting for our questions. In the end, we stand before the great cosmic mystery with more questions than answers. The theory of evolution by natural selection provides a powerful, evidence-based explanation for our origins that requires no outside intervention. It is the foundation of modern biology, and it tells a beautiful story of life's tenacity and creativity over billions of years. The alien creation hypothesis, on the other hand, offers a tantalizing, dramatic alternative. It weaves together ambiguous clues from genetics, archaeology, mythology, into a narrative that speaks to our sense of wonder and our feeling that we might be special. It's a story you can't easily unsee. As of today, December 9th, 2025, there is no credible, scientific evidence to support the claim that aliens created humanity. The clues remain speculative, and the arguments rest more on interpretation and imagination than on verifiable data. Science continues to build an ever stronger case for a natural, terrestrial origin for our species. However, the absence of evidence is not evidence of absence. The spirit of science is not to declare a question closed, but to admit what we do not know and to keep looking. The universe is vast, and our ignorance is vaster still. We should not be afraid to ask big questions, strange questions, even uncomfortable questions. Perhaps the real value of this hypothesis is not whether it is true or false. Its value lies in its ability to force us to look at ourselves from a new perspective. It makes us think about the nature of evidence. It challenges us to defend what we think we know. It encourages us to imagine possibilities beyond our current understanding. It connects our modern scientific quest with the ancient mythic search for meaning that has defined our species since we first looked up at the stars and wondered, how did we get here? It is a thought experiment on a planetary scale, so we must continue to search. We must keep sequencing genomes, digging for artifacts, listening to the silent whispers of the cosmos. We must do so with minds that are open, but not so open that our brains fall out. We must embrace the rigor of the scientific method, while also honoring the profound sense of wonder that drives us to explore. Whether we are the children of stardust and time, or the children of forgotten starfarers, our destiny is the same: to keep asking questions, to keep learning, and to continue our journey of discovery into the great universe. The beautiful universe, the mysterious universe we call home.